Welcome to my lecture. Today I will discuss isothermal process. The thermodynamic process the thermodynamic process in which the temperature of the system remains constant is known as isothermal process. The thermodynamic process in which the temperature of the system remains constant is known as the isothermal process. In isothermal process, the temperature of the system remains constant, so the Boyle's law can be applied. Let a cylinder filled with gases and fitted with a movable piston be our system. Energy can go out and come in through the cylinder. If energy is supplied to the system very slowly, then the pressure and volume of the gases will be changes, so its temperature will remain unchanged. Such change is known as an isothermal change. The expansion of the gases due to this change is known as the isothermal expansion. The PV curve for isothermal process. This curve is known as isothermal curve. This is a rectangular hyperbola. In isothermal process, if the volume is increases, the pressure is decreases. And in isothermal process, the temperature remains constant, so the internal energy of the system doesn't change. That's why dU is equal 0. Since T is constant. So, from the first law of thermodynamic process, we get dQ is equal 0 plus dW. That is dQ is equal dW. I mean, in isothermal process, the work done by the system is equal to the heat energy supplied to the system. In isothermal process, P1 is equal P2 V2. In case of isothermal change, in case of isothermal change, PV is equal nRT, or P is equal nRT by V. So the total amount of work will be W is equal V1 to V2 PdV. P1 V2 nRT by V dV. nRT V1 to V2 dV by V. nRT ln v b1 to b2, since integration 1 by x dx equal ln x. nRT ln v2 minus ln v1, nRT ln v2 by v1. This is the total amount of work in isothermal process. Today this is last. Thank you. See you next lecture with Physics Academy. Stay connected.